Hello everyone, this is Alex with Lights Out Programming. I just wanted to show you the beginning of my maze simulation. I just completed the first building, uh, our path finding algorithm, and the first A-star algorithm, which is a solving algorithm to solve a maze. I just wanted to show that off. This is not the complete project. I still have a ways to go to optimize it, but I just wanted to show it off a little bit. So I'm running it right now, and I'm also going to show you the code afterwards. But for now, I have a generator with these algorithms. Um, so at the moment they're just strings, but eventually I'm going to implement every single one of them. And let's just do simulate all. So this is going to simulate um, generating a pathfinding algorithm for the maze and a solving algorithm to solve the maze. And it's going to look like it takes a minute to load. I need to optimize this somehow. Here we go. That took a minute. So right now it doesn't look like anything too special, but I'm going to show you how it actually generates now. So this is the pathfinding algorithm to build the maze. So what you gotta do is generate the maze, and then if you hit start, you can see it starts building a maze. It's a little slow right now, just the data structures I used aren't optimized at the moment. So the reason why it starts to slow down is because it searches through each one of the grids every single time, and it keeps adding to a list every time um, it goes through one of the grids, and so the list just keeps getting bigger and bigger. So that's why it starts to slow down. And so as you can see, maze is done. No more steps, and now we have a maze. And then if we repeat and we from here, you can see this is the solver and this is the end. And the maze actually generates randomly, so it's never going to be the same maze. But if you hit start, you can see it's starting to solve with the A-star algorithm. And I'm going to go over the algorithms once I'm done with the project. But those would have to be their own separate videos. And I'm having the same problem with the solving algorithm where it keeps adding to the list, except the list is even bigger because it it's a list full of the maze building algorithm, and it's adding another list of neighbors for the searching algorithm. So now it's just gonna, this one takes a minute to complete. Oh man, it's pretty slow, pretty slow. Yes, this definitely needs to be optimized. Let's see, it's almost there. Come on, baby, you can do it. I'm also running on a 2015 MacBook Pro, so this is definitely not the fastest computer. Um, let's see if it actually makes it to the end. It should. Hmm. Okay, it's checking that one. Oh man, this thing's struggling. Okay, so I'm actually gonna stop it right now, but it's eventually going to get to the end and it's gonna stop searching. Uh, let's see. I don't really want to stop it. It has about one more minute, I think. So I'm gonna let it run. So maybe if you guys are watching the video right now, you can, and once you see the code that's actually running the simulation, maybe you guys can give me some tips on how to actually optimize it. Right now, I'm using a hash map with a few array lists. So there's really about 3 or 4 lists that it's going through at the moment. Um, and so I'm gonna have to figure out a way to make it a little bit faster. Well, a lot faster. So the problem here is, so I have an array list for an actual path. It's gonna find the fastest path. I have an array list of just all the cells. I have an array list of just the searching cells. Um, I think that's it. Um, there might be a list I might have to clear somewhere because I don't think it should be going this slow. Um, come on, baby. 2 more steps. 2 more steps. All right, finally. And then here, path found, path found. So I'm gonna stop this. So actually, I'm going to implement. It's not showing the fastest path. The yellow is actually everywhere that it's searched to find the end path. Um, but the fastest path is going to be represented by a red line from start to finish. Okay, so there's my project so far. And let me go through some of the code. Um, so if you've seen my other videos, I usually start with the main class, and this is going to hold just a page going to my start page. I think I said that wrong. It's going to create a scene for my start page. And then from that, I'm going to have my maze controller. And this is going to, uh, this class is the one that I first showed you where it says simulate all button. So it's actually going to simulate every step of the generation, or I guess the simulation. And then it's just going to basically show you the final product. And so let me just go through this really quick. These are the buttons, the elements, and then here, this is where I'm making the size of my maze. You can put this to any size, but for now I'm doing 1010 because as you can see, the larger the maze, the more processing power it needs. And my computers just can't handle it at the moment. And then I have a movement for the animation. That's how the start button works. It starts the animation timer, and then it has a step, and for every second, it's going to make that step. Here I'm simulating, initializing the mouse speed and the slider mouse speed and the slider maze speed. At the moment, those aren't working. I just need to connect it to the animation timer, and it doesn't seem to be working as well as I wanted to. I might switch to a timeline, um, but we'll see when I get there. And then this is the beginning button. So you need this to start the simulation. As you can see, these methods, I am generating it step by step. Um, I'm trying to do it as object oriented as possible. And then this is going to be the animation. This is going to be the stop animation. And this is my step. So every time I step in my animation timer, it's going to go all the way through to the end. Okay. So that is my maze controller to simulate everything. And then basically it's a rinse and repeat. So the generation page controller, it just does the generation maze path and it makes the positions. The same for the solver, it just does it makes the maze and then it gets to the path, but it doesn't actually solve the path. You just have to use this animation start button to solve it, or you can just use the generate solving path and it'll create it. It'll show you the end right away. Starting page. It has 3 buttons. So the first one goes to the simulate all. One goes to the generation page, so you can see the steps for generating a maze, and then the solving page, which shows you the steps that simulate solving the maze. And so right now, I only have one of these generating mazes, and it's just randomly generating a maze. So basically, it's going to find the starting node, and then it's going to find its neighbors, and then it's just going to randomly pick one of those cells. And then one of the cells that's picked, it's now going to be the current node. And then from that current node, it's going to pick one of its neighbors that hasn't been visited. Um, and it's, so on and so forth. And it's going to create the maze that way. As you can see, this is the main method that picks a random neighbor. And then now we're going to have a random maze builder. And it's going to do exactly what I just said. So now let's go back to, let's show the cell model really quick. So the cell model is going to hold neighbors and solving neighbors. and it's going to have all these properties. Let's see, anything interesting. In this class, I'm also drawing all the elements of the GUI. So whenever a move is made, it gets drawn from the cell model. This is probably not the best way to draw a cell. I'll probably end up moving this away into another class. Direction hasn't been used yet. I made a grid position to have the grid position of the cell, which is the row and columns. I have a cell coordinate, which is the position of that cell in XY position. My maze simulation that holds basically connects everything together. So here is where you're going to have generating grid positions. It's generating the maze path, the maze building, and the solving path, and then the solving algorithm. And then this is where we're going to move. And this is for like the steps, basically. And then here I'm drawing every cell every time. And then within every cell has two other array object lists, and it's drawn from those also. So you can see it's pretty slow. Then I have the states, which is what's getting the color, the solve states, and that's basically it. If you guys have any questions, please leave them in the comments. And I do plan on updating this video, and once it's actually optimized and completed. Thanks for your time. Have a good day.